Good morning, everyone. So this is a short talk. I'll talk about myself as little as possible. I'm with the Intraverse Institute. What I will say is that I come from, my career is spanned from software development into project management. And the actual framework that I'm going to run through today is actually going to be looking at both of these elements. So it's really, it's a full-day workshop that I've compressed down a lot, and we're really only talking about 2 slides. So it's going to be a nice and easy introduction to the day. There we go. So what we're talking about today, sorry, this sounds far too loud to my own ears. What we're talking about today is distributed ledger application, infrastructure stack, as well as the project management life cycle of it. So there's a number of different models around that people use, and I find the most useful models are the ones that you can actually understand, comprehend, and apply. So I find 4 layers to actually be the easiest for people to comprehend. So you start with your underlying infrastructure at the bottom, right? This is where you've got the internet. Now, I think you can technically subdivide that up into 6 layers on its own if you want, but that's sort of, you have your infrastructure. You have, then you've got your protocols that sit on top of that, right? This is your actual blockchain that you're running, your platform, your Ethereum network, or your Stellar, or your Ripple, or your Hyperledger, or whichever platform you're going to be using, right? That determines the protocol. That determines the protocol through which you establish the consensus. And up above that, you've got your services layers, right? So generally, a blockchain by itself isn't actually particularly useful. For most of the applications, you're going to be talking about moving a lot of data nowadays, and you're going to need a separate distributed data storage as well, right? The standard blockchain architecture replicates all the data to every single node. That is a terrible idea if you're talking about, some sort of medical data application, and you've got, 1 billion people times 20 terabytes of CT scans, right? It just doesn't work. So you separate out some of the data storage from the actual, right? Identity is another piece that goes in that services layer. So most applications will need some form of identity. Fundamentally, having no identity, as the idea was with the Bitcoin blockchain, it's fundamentally socially corrosive, right? If you don't know who your counterparties are, how do you hold them accountable and responsible? The only thing you have then is making sure every single contingency is managed within the blockchain protocol. And I don't know if anyone here has ever signed a legal contract, but you know how many different edge cases there are for even the most simplest of agreements. I'll talk about that a little bit more later. So yeah, I've got the example there is proof of work consensus. Obviously, if we're talking about the enterprise applications, or we're talking about using something like Hyperledger, then you've got different consensus models that come out there. I expect we'll see more different forms of consensus. There's some very interesting ones out there, but they're outside the scope. For now, suffice to say, this is the level where it occurs. The services. IoT, there's a lot of talk about how blockchains will interact with artificial intelligence, machine learning, and IoT. I actually think to some extent when you come at a supply chain problem from the blockchain end, and you say what we then need to do is we need to add IoT sensors at every step of the way, I actually think it's inverting the problem to some extent. What you're doing is you're implementing an IoT solution to fix a supply chain, and then you're adding blockchain to actually store that data, as opposed to you're implementing a blockchain solution and you're just adding IoT sensors, to do that little bit of capturing all the information along every point in the chain. So, but those are the services, right? This is where all your oracles go. This is where all that interaction with the real world on the data level. And then you've got the application layer at the top, and this is where your user interfaces go. This is also where I think we'll see most of the AI actually being implemented in making those user interfaces friendlier. Today AI tends to be at that sort of, chatbot and voice recognition type level. That just makes user interfaces that much friendlier. So now I personally think that the word wallet has been overused. Really, I think app is really the general term for it, because for most enterprise applications, it'll be a particular application that you use, whether it's on a mobile or on a desktop, doesn't matter. And wallet really only applies when you're talking about tokens and cryptocurrencies. Next, we've got the two boxes on the side. Now, security, right? The whole cybersecurity piece, that is incredibly important, and that will extend throughout the entire stack, right? I've simplified it somewhat, but you've got your information policies, right? Your design, I've put that at the top layer in terms of people determining what information will be shared, what will be stored on the chain, who has access to that, and those sorts of policies that you take into account as you're designing your solution to start with. Now, penetration testing, you should probably be doing that far deeper into the protocol, but a lot of that, should already be taken care of by the underlying blockchain platform. So when you're developing a particular application on top of an existing set of infrastructure, the focus will be at those top layers. Below that, you've got logging to make sure there's tamper evidence, because all the blockchain itself should be tamper evident, if not completely immutable. When you're starting to interact with third-party services and that sort of thing, that's where, especially when your legacy data systems and that sort of stuff, you need to be logging all of that sort of stuff there. And finally, you've got the encryption that should be at the lowest level you can possibly do. Don't add it as an afterthought into the way you do these things. Now, again, depending on what level of the stack your application is at, some of this will already be taken care of for you. Now, one of the things that is unusual about the blockchain space is that because of all the hype created by all the ICO projects, people's imagination is much more easily captured at that top application level. So a lot of the advertising and the marketing has focused on, oh, we're going to completely change this and completely change that. The equivalent in sort of that metaphor of this is a new layer of the internet rolling out is everyone had just started to get, the earliest modems to connect to the internet. And rather than everybody saying, we're going to build better infrastructure, we're going to lay, bigger pipes, everybody was promising to give them streaming Netflix into their bedrooms. And yes, people were excited by that, but guess what? It took, from the invention of the steam engine, it took about 25 years for the first passenger train. From the invention of blockchain, we're now 10 years down the track, and people are coming to me going, show me where it's working. Show me how it's transformed the whole world already. And the fact of the matter is, the projects that are out there that are working, that are actually, in improving the supply chain, they're below the surface, right? You don't notice it, you won't talk about it. So how will we know when blockchain technology is mature? That's when nobody's talking about it anymore, right? Pretty much that. So a lot of promises have been made at that application level, but today, really the building is still at the protocol level, at that laying that fundamental infrastructure until we can get to the kind of throughput that large enterprise applications are going to require. Finally, I've got the governance piece on the end, right? And this, I think that a huge lesson we can learn from the early projects that have basically said no to on-chain governance. When you don't explicitly specify governance, it will happen anyway. And today, the maturity of blockchain is simply not there for on-chain governance. So you need to specify how decisions will be made off-chain. Outside of the actual application you're building, how will the different participants in the network, right? How will different businesses in your supply chain actually govern the decisions that are made? So the most common sort of supply chain application that people are talking about, really what you're doing is you're creating a vertically integrated company from different companies along the supply chain, right? So that in itself is a new type of organizational structure. So rather than having one massive company that is responsible for everything along the supply chain, you have multiple different companies that perform their role and they're communicating across the blockchain. That's sort of the most common example. So what you've got there is you have, a lot of considerations in terms of your design cycle, which I'll talk about shortly, of engaging different stakeholders in that decision-making process. Specify it upfront as early as you can, because everything that's not specified will tend towards tyranny, will tend towards chaos and disorder, and whoever has the loudest voice or the most clout financially in that supply chain or in that network of businesses will tend to dominate the decision making, right? So make sure that there are processes in place because they'll happen anyway, right? At the moment in some of the public chains, you have Twitter wars going on, you have Reddit threads where everybody's hurling insults at each other because there was no specified process. And if it's not there, then something is going to happen. People are going to come to those decisions by talking to each other in some mechanism or other anyway. Now I've got a few layers out there as well. You've got that infrastructure piece at the bottom again. You've got your legal jurisdictions, right? Now this you could draw as an entire box around the whole thing because the entire project you're doing actually falls within a legal jurisdiction. I don't have time. Falls within a legal jurisdiction, right? So the state where you are is responsible for certain aspects like protecting property rights and enforcing contractual obligations. So if you've got smart contracts and you've got digital assets that you're transferring, you are doing this within a legal jurisdiction. And to the extent to which you're actually substituting for some of those controls is the extent to which you're saving a lot of costs in terms of the enforcement of contractual obligations and property ownership. You've got the legal structure side of things, right? So is there going to be a separate organizational structure that actually governs this particular blockchain project? Is it a consortium of different companies that are coming together? And what does that look like legally? What's the actual legal structure? Where does the liability sit? Who pays for the development of this particular blockchain solution. Who pays? Who's responsible when things break and mistakes are made? Access and permissioning, right? So that feeds into that earlier thing. Who has access? Who has permissions to view which pieces of data? Permissions to change which pieces of data? Who are your, if you've got a consortium sort of system, then you'll have a certain number of permissioned authors of your actual blockchain writing additional blocks, and you've got a larger number of users outside that who can request transactions and or view the actual data, right? And you've got regulators in that bucket as well. And finally, at the application layer, you may well have reputation and potential voting schemes as well. So they're at the top level. All right, that was one slide. And now we have the second, which is sort of, the project management side of things. So I've been calling it the distributed ledger application development lifecycle, because if you take the standard software development lifecycle, the SDLC, there's a few peculiarities when it comes to blockchain projects or distributed ledger applications. And the main thing to note is that although it's kind of difficult to picture it here, I actually view this as being very well suited to agile and iterative development. And therefore, I actually picture this in my head as more of a spiral. So you've got your dimensions of the who, why, how, and what that you take through the entire cycle, and each will inform the others, right? So you have to make sure you know who this project is for. So who are your participants? Who are the key stakeholders in your, let's say, supply chain? Because you need to engage with these people as early as possible and involve them in the design. So then you figure out why, right? What are the key problems you're trying to solve? If you're not trying to solve a problem, then why are you going through the incredibly costly and challenging effort of doing something that probably hasn't been done before? So, right, and what's the value you're trying to realize? And what you'll find is that the value that blockchain provides is proportional to the number of poorly trusted participants in that network. So not just network effects that scale, but network effects that are proportional to the lack of trust, right? If you're implementing a blockchain project only within your organization, you're wasting everybody's time. You can use a database and you can log some access and, have certain, like, we've been doing that for a long time and it's pretty much worked. And then what, right? So when you figure out why you're doing what you're doing, you start to go into the design of what that's actually going to look like. What are the agreements that are going to be made? What do smart contracts look like? What kind of protocols are you going to use? And that really gets into the how, right? So you know what the agreements are between people, and then how is that actually going to be implemented? Now, the how specifically, that question, because of the nature of blockchain and the nature of the space in general, most of this space is open source, right? There's a lot of advances being made in the open source space, and a lot of trust to be gained by actually sharing a lot of the smart contract code with all the other participants, so they can be confident there's no backdoors and all that sort of thing. So from an enterprise perspective, you're going to need to figure out your strategy around open source technology, right? Will you seek to be compatible with open source standards as they emerge? Will you use open source technology in your own platform, and what are the licensing requirements and stipulations on that, right? These are all sort of considerations. Will you open source what you're building so other third parties can build on top of it and extend the scope and scale of your actual solution, right? Or will you be completely permissioned and there's a small little black box of just the participants in your network that have access to how this whole system works, right? And there's trade-offs at every step of the way, but you need to have a strategy. That's really what I'm saying. All right, so the whole thing is that these networks are complex systems, right? So each of these things starts to inform each of the others. So you might find that as you start to get into how you're actually going to implement these things, that additional stakeholders pop out, or at least, or at the very least, the willingness of different stakeholders to participate and cooperate in this process is going to be tested and challenged through this process as you negotiate what this looks like, which changes, the objectives on some of these things, and et cetera, et cetera, et cetera. So as you go through, you start going through your planning side of things, exploring conception, right? Doing your feasibility. And there at your feasibility side of things, you sort of evaluate what is the value, right? Is there a business case here? Is there enough value that's currently being wasted that can be captured or generated for this to actually be worthwhile? All those sorts of things. And then when you start building and piloting, you've got your technology choices in there as well. It's actually not uncommon for something to be tested in one platform and then finally built in another. In some cases, you may actually do your proof of concepts on multiple platforms where it's cost efficient to do so because you don't know what you don't know about what won't work. One of the things to note here, and I could have put it under the security side of things, if you're looking at the, questions will be at the end, so I will come back to you. So, especially when you're looking at public blockchains, there is a really high cost to setting up duplicate layers of infrastructure. So where you have your standard software development lifecycle and you've got your dev environment, you've got your staging environments, you've got your UAT testing, you've got your test, you've got your, you've got your prod, you've got, people can expand these depending on the nature of that different platform. If you're talking about public blockchains, of course you've got test and you've got main, and that's it. Because giving duplicate platforms is incredibly, has a lot of overhead to it. So make sure you pilot things properly and keep reiterating through and negotiating iteratively each step of the way. Finally, at the end, governance becomes really tricky. So where your release management normally goes, here you have that entire governance piece of how you make decisions, of whether you decide to implement changes, whether you stop what you're doing altogether, whether you duplicate it and you're able to set up different versions of it, or whether you can scale up to a larger scale. And that was it. We have a question from down the back.
Thank you. Can you hear me?
Yep.
The theme of the conference is enterprise blockchain. So, and your session is on blockchain technology framework. So, for enterprises, there are multiple technology options available within blockchain. You mentioned about a few of them,
yep.
Hyperledger, Ethereum, and all that. From your experience, do you have a comparison as to which one is the right fit for which industry, for what kind of use cases? Do you have some recommendations or comparisons?
So really that comes down to the requirements that you have. Hyperledger is good. Hyperledger would be the safest option to pick for most enterprise applications. I think that's the really short answer. If you're looking at, using public chains and that sort of thing. There are use cases for Ethereum. It's quick to stand up. There is Quorum from JP Morgan, which is the enterprise version of that. And, you know, that's definitely a good second option. For the financial services industry, you can look at things like Polymath, Corda, and Ripple, or Stellar being the open source variant of that, if, you know, depending on who the actual end users are of that. But there are other architectures out there that are simply not as mature, so these are the main contenders to that space. And yeah, Ethereum tends to be the easiest to stand something up in because all the infrastructure is already out there. However, it won't scale generally to what enterprises will need today. So with Hyperledger, you have a bit more control, and the fact that it's available as a service means that you can stand up your different test and staging environments as required and then shut them down as well, a lot more easily than you can with any of the public chains.
Thank you. For financial services, you mentioned a few of those. Do you have any recommendation as to which is the best and why, specifically for financial services?
I think that's something that we can discuss offline and go into the actual requirements, because of course just financial services is quite a broad field. So if you're doing international remittances to other banks, well, Ripple is doing that, right? That would be the first obvious choice, and why wouldn't you? If you're setting up a stable coin, for instance, as your service, there are dozens of companies that are seeking to do their own stable coins because they want to put themselves at the top of a, you know, flat hierarchy, right? So there's different financial services. There are interesting developments in the security token offering space and the Ricardian contract space about tying actual issuance of tokens to underlying legal contracts. And I think Polymath is very interesting in that space, but I would have to actually see how that plays out, or 0x protocol, for instance. I'd have to see how they play out to actually give a solid recommendation, but certainly those would be the places I would be looking in terms of my proof of concepts.
Thank you. I have a point with respect to, like, currently there are some threats with respect to quantum computing, right? So how you are thinking with respect to that? Quantum computing threat.
Sorry?
Quantum computing threat.
Oh, okay. Yes, it will make processing faster. In terms of will it invalidate proof of work and that sort of question, it's not something that I'm worried about. If someone has sufficient power to actually break encryption, if that's really the underlying fear, then the first place you would use that is probably on nuclear launch codes and not to try and get into people's, you know, private keys. And in terms of proof of work, someone doing a 51% attack on, say, the Bitcoin blockchain, which is the biggest one that's actually using that, really, that's only a risk if only one party in the world has quantum computing and nobody else does. So really, it's likely that, you know, that would only be a very brief period of time, and because of the financial interests in there, as everybody scales up their processing, that is balanced out, as well as the fact that there are already people working on quantum resistant, you know, algorithms that basically are equally difficult to process for quantum processors. So it's not really a concern as far as I'm concerned. This wouldn't be the first place to actually target. And some of the different chains that have different consensus algorithms, it doesn't actually apply as a concern.
So you mean like a consensus algorithm, if you use differently, no need of worry about quantum computing threat?
Well, you can substitute the hashing algorithm for another one in these chains without, it's a fork, but it's one that arguably, if someone shows up tomorrow with a pocket-sized quantum processor and is processing suddenly 90% of the Bitcoin blockchain hashing power, then I think it's a fork that people would be quite happy to actually upgrade the hashing algorithm to be resistant to that. Right, so yes, there is a fork involved.
Thank you. So, what would be what should an ideal team for a blockchain implementation look like? Who all should be involved in it in a project?
Well, ideally, stakeholders from all the different organizations that are going to be impacted by it. There's a risk of there's an inverse proportion to the lack of trust and the usefulness. So you may have a supply chain with one incredibly dominant participant, like IBM and Maersk working together on supply chain in general. However, if that's the way you build it out and implement it, yes, it's far easier to build, but you might struggle to get your adoption because everyone in that industry is actually a competitor to the heavily dominant player that's built it. If you've got a more flat, more even ecosystem, you want to involve as many of the players. For starters, in terms of the fundamental team, you're going to need an architect, you're going to need your developers, you're going to need someone to really worry about the user experience side of things. Basically, the same people that you would have on any software development project come into mind. It also helps to have an economist or someone who specializes in mechanism design and sort of the psychology